So now that we have a better understanding of slope, we're going to start taking a look at a specific situation where slope comes into play in regards to proportionality. All right, so in this lesson, we're going to see a lot of situations where there's some kind of proportions at work or proportional reasoning. For example, take a look at this situation. Typical employee-employer situation, you get paid $12 per hour. All right, so let's say I want to start talking about graphs and slopes. In this lesson, we're going to look a lot at these situations where there's some kind of proportional relationship. In other words, in this case, I get paid $12 for each hour that I work. So 1 hour, $12, 2 hours, $24. There's that proportional relationship going on. What if we were to graph this one? This class has a ratio of 4 girls to every 3 boys. So if I bump up the number to 8 girls, there should be 6 boys. 12 girls, there should be 9 boys. There's that proportionality going on. Or maybe it's just a recipe. A recipe calls for 1 teaspoon of salt for every 2 cups of sugar, and that proportional relationship continues throughout the problem. So what we want to start talking about is, what does that look like when we graph the situation, when we start introducing the concept of slope? All right, so let's take a look at that second situation. This class has a ratio of 4 girls to every 3 boys. So let's just say I put that on a coordinate plane. Let's make the x-coordinate the number of girls, the y-coordinate the number of boys. Okay, and what we get are just points based on this ratio. For every 4 girls, so if I go across 4, I'd go up to 3 boys, and that would show the correlation between those two units, 4 girls, 3 boys. Now, let's say this was doubled. If it was 8 girls, well, then this would have to be 6 boys because I'm using proportional reasoning. So 8 and 6. If I triple it, I'd get 12 and 9, and I would just keep going. 16 and 12, 20 and 15, and then 24 and 18. And so what you'll notice is we get a graph. And we also get that concept we talked about in the last unit, which is there's a correlation between this ratio and the slope. For every 4 girls I ran across on the y-axis, I rose up 3 boys. So up 3 over 4, up 3 over 4. Okay, so kind of pay attention to that because we're going to revisit that stuff some more. All right, so the idea here is that there's what we call a direct correlation between the girls and the boys, between our units, or what we call a direct variation problem. So here's the textbook definition of proportional relationships. It's something called direct variation. It means that there's a direct correlation between my values for x and my values for y. In that example we talked about just a minute ago, the direct correlation was that for every 4 girls, there were 3 boys. And there's a direct tie-in, very direct connection between the two. All right, so our definition here says that when 2 quantities, whatever they happen to be, x and y, boys and girls, hours and money, whatever, when those are proportional, the relation can be represented by the direct variation equation y equals m times x, where m is what we call the constant of proportionality. All right, so this equation is the direct variation equation. And you can see what we mean by a direct connection, that if I plug in x, all I have to do is multiply it by this constant of proportionality, and it directly takes me to y. It's a very simplistic equation. There's a very direct connection between x and how I get y. So then the graph will just end up being y equals m times x. That's the equation we would use to graph our proportional relationship. And what's going on here is they're also trying to show you on this graph that m, which up here we're calling the constant of proportionality, also turns out to be the slope on our graph. So this constant of proportionality is another way of saying that's the slope of this problem. Now, here's another little thing. These types of graphs will always pass through the origin. They will always pass through 0, 0. And that makes sense, because if we're talking about proportional reasoning, let's go back to our example here. If for every 4 girls there are 3 boys, well, if there's no girls, then there should be no boys as well. Okay, if I go back to that very first slide, you get paid $12 per hour. But if I've worked 0 hours, at that point I should be getting 0 pay. I haven't started working yet. A recipe calls for 1 teaspoon of salt for every 2 cups of sugar, but if I haven't put in any salt yet, then I shouldn't be putting any sugar in yet. I haven't even started making or mixing the recipe. Okay, so when proportionality is involved, that's one of the other key things we should understand, is that one of the points is going to be 0, 0. We're never going to have a situation where we start our graph at anywhere except the origin. Alright, so again, the key things to pull away here is that when we're dealing with proportional reasoning, proportional relationships, that they can be represented by this direct variation equation, y equals m times x, where m is something called the constant of proportionality, or the slope.